Now we're going to talk about one of the most important concepts in physics, which is gravity. It's so important is because we're always affected by gravity. Gravity is holding me to the ground. I put a paper down and I know it's not going to float away. I drop something, I know it's going to fall. So acceleration due to gravity is such an important quantity in physics that it has its own symbol, which is little g. And you'll notice there's a little arrow over top of it, which means it's a vector quantity. It has direction. Near the surface of the planet Earth, the value of g is 9.8 meters per second squared. The direction of the acceleration due to gravity is always down towards the center of the Earth. So it doesn't matter where on the planet you are. You could be on the South Pole. You're still going to point it straight down. So this number, 9.8, is an important number and is one that you need to know. So let's try an example. A girl throws a baseball straight up at 15 meters per second. Well, 15 meters per second is our VI, our initial speed, or velocity. And that is in the upward direction. What is the ball's velocity? So we're looking for VF, question mark. 2 seconds later. Well, seconds is indicating time. When I look at this given information in my 5 physics formulas, I realize none of the formulas work, and that's because of this concept of gravity. So on the planet Earth, if anything is dropping, being thrown, you can always make the assumption that gravity, the acceleration due to gravity, is 9.8. So it's no longer going to be a given piece of information in the question. So again, if you're throwing a ball up or down or dropping it, you can always make the assumption that little g, which is equal to the acceleration due to gravity, is 9.8 meters per second squared. And that's important to realize. It's not going to be part of your given information anymore, but you do need to write it down. So when we look at our 5 physics formulas, I'm going to use the formula A is equal to VF minus VI divided by T. I'm trying to get VF all alone. So the first thing I'm going to do is remove the T. And the reason I do that is because when you have fractions, it's as if the numerator is inside brackets. So the opposite of dividing by T would be to multiply by T. So I'm going to times both sides by T. That's going to give me AT is equal to VF minus VI. Now to get VF all alone, I have this minus VI. The opposite of minus VI would be to add VI. So the VI's cancel. And I'm left with VF is equal to VI plus AT. I could have wrote AT plus VI. It makes no difference. It's like saying 2 plus 3 or 3 plus 2. You're always going to get 5. Next thing we do is we plug in our information. Now, when I look at my given information, I forgot to write down the down. This is up and this is down. That's a problem. Okay, your arrows need to be pointing the same way. So when I first write this out, if I write down 15 up, I'm in the wrong color, plus 9.8 down times my time, which is 2 seconds, I need to fix one of these. And it doesn't really matter which one I pick to be negative. I'm going to pick the up one to be negative. So I'm going to change that to minus 15 down, plus 9.8 down, times 2. When I place all that into my calculator, I end up with 4.6 meters per second down.